Welcome everyone to the Moldex 3D webinar series. My name is Alex Baker from the Moldex 3D North America office here in Farmington Hills, Michigan. Today's topic is going to be gaining insights into the black box of material properties, trying to unveil some of the mystery around material properties and how we actually do go about our characterization. Okay, so as far as the injection molding, or really any process goes, there's a bunch of key successful factors on molding quality. I'm going to focus on injection molding here, as we can see the injection molding machine. As the material flows into the mold, or even through the barrel, the same thing applies. We have a velocity profile. That velocity profile, there's going to be some sort of shear associated with it. That shear is going to induce temperature. And that temperature is going to, it's going to be different in different regions of the mold. And as the material cools down, that material is going to shrink. Ultimately, that material is going to shrink differently in different regions of the part, which is where we get our warpage from. So the material properties allow us to consider all the variation in the plastic property that would happen throughout the injection molding process, and ultimately, as it applies to other molding processes as well, like compression molding, like Mucel, like all these advanced molding processes kind of hold the same material properties. And from this, we're able to see all of the different molding defects that you might experience in reality. That's really one of the core benefits of using simulation, is being able to predict these issues before they pop up in the real molding process. Being able to mitigate these issues helps us to reduce the amount of cost associated with mold trials. But it also helps us to maybe change our tooling design before the tool is actually built, so we can prevent having to iterate that tooling design. All right, there's 5 core properties that we focus on as far as the material file goes in Moldex 3D, and all of these are helping us to solve the constituent equations for mass balance, momentum balance, energy balance, and for thermosets, the conversion balance. We have the viscosity, which describes how the ability of the material to flow, or really, as it directly relates to viscosity, the resistance of the material to flow. PVT allows us to describe the shrinkage of the material at different properties, or at different conditional, as the material experiences different conditions in the mold, both for temperature and pressure. We'll see that later. Heat capacity and thermal conductivity are thermal properties. And then the mechanical properties, things like your Young's modulus, your Poisson's ratio, all of these help us to describe the strength of the part or the modulus of the part in the different regions of the geometry after the molding process.